Good afternoon, everyone. I'm Sushil. Today I'm going to present on TiO2 surface with acetonitrile. Starting with the introduction, the use of acetonitrile as a solvent in DSSC can increase the absorption in spectra by more than 50%. This acetonitrile actually enhances the electron injection from dyes to TiO2, making it one of the best solvent for DSSC application. The effect of this absorbance of acetonitrile in TiO2 is also useful for sensor application, where the change in conductivity due to absorbance is the key for the sensor application. Similarly, density of state and absorption spectra are useful to study the optoelectronic property of molecule, as well as the heat simulation gives insight on heat treatment of molecules. So my objective is to simulate acetonitrile on top of TiO2 molecule using WASP to observe the effect of adding acetonitrile on TiO2 with dose and absorption spectra, and also the study of effect of heating TiO2 with acetonitrile. This is the theory. Here I have included the total energy for CHEM792 theory, which considers the electron as a system of non-interacting particles with the same density. The total energy is given by this equation, which is dependent on charge density. I'm not going through details of this one. So this is the methodology for doing simulation. We used Gaussian as well as WASP. The details are provided by our instructor. So I'm also not going through all of them. This is the result section. Here you can see on the left hand side we have TiO2 with acetonitrile on top and bottom of z-axis. We can see here I have analyzed the total energy. The total energy without acetonitrile, that is just for TiO2, is given by this value, that is 445 electron volt. And with acetonitrile we can see the rise in total energy, which is due to the structural discrepancy, so that we can say the acetonitrile, the titanium dioxide alone is more stable than with acetonitrile. We have also calculated the energy per molecule. This slide shows the dose and spectra plot for acetonitrile with TiO2 with acetonitrile. On the left hand side we have the dose plot, which shows the band spectrum, as well as on the right hand side we have spectrum plot, which shows the absorption. The dose gives an idea about HOMO-LUMO of molecules as well as band gap, and the absorption spectra gives the information on absorption range, the frequency range. Here is the heat simulation for this acetonitrile, TiO2 with acetonitrile. We can see on the right hand side I'm increasing temperature from 0 to 1000 Kelvin, and we can see this acetonitrile molecules takes out one oxygen from this titanium. This CH3CNO molecule is actually the Lewis structure of methyl isocyanate. There are 3 resonance forms for this structure, and the one we are saying could be one of the 3 that I have given on the bottom of this slide. So it exists in the form of hybrid form. It exists in hybrid form. So in conclusion, WASP is useful simulation software for molecular analysis. The energy calculation is useful for analyzing structural discrepancy and stability of molecules. Dose and absorption spectra gives optoelectronic property of molecule, as well as the heat treatment study, so that acetonitrile takes away one oxygen from TiO2 and forms methyl isocyanate. And my future work will be to observe different orbitals using partial charge simulation, which I have already submitted the job, but it's still in running condition, and to simulate the same structure for a small and large number of acetonitrile molecule and observe its conductivity for sensor application. Thank you. And lastly, I would like to thank Dr. Kilin, Jeff, Vinu, Stephanie, and all students from USD for their valuable support and suggestion. Thank you.